Let's look at some of the reactions of acids, bases and salts. The first is when we treat a metal with an acid, it always forms a salt and hydrogen gas is released. Let's look at an example. So we have magnesium metal, it reacts with HCl, that is the acid. So it forms a salt which is MgCl2. And hydrogen gas is released. So now let's balance it. So whenever a metal reacts with an acid, it forms a salt and hydrogen gas is released. So we have different examples. Whenever zinc reacts with an acid, it forms zinc chloride, the corresponding salt, and hydrogen gas is released. Similarly, when iron reacts with sulfuric acid, it forms the salt and hydrogen gas is released. So whenever a metal reacts with an acid, it forms a salt and hydrogen gas is released. Whenever an acid reacts with a base, it forms salt and water. This reaction is known as the neutralization reaction. Let's look at some examples. We have copper oxide. It's a base. It reacts with an acid, sulfuric acid. It forms the salt CuSO4 and water is formed. So acid-base reaction gives salt and water. Similarly, NaOH, sodium hydroxide is a base. It reacts with an acid, HNO3. It forms the corresponding salt, that is NaNO3, and water is released. So acid-base reaction is known as neutralization reaction. It forms salt and water. Whenever we see a carbonate, we know that carbonates always release carbon dioxide gas. So in this case, we have calcium carbonate. It reacts with HCl. So it forms CaCl2, the corresponding salt. Since it is a carbonate, it always releases carbon dioxide gas and water is formed. So in this case, when we have calcium carbonate, it forms the salt CaCl2. Since it is a carbonate, it always releases CO2 and water is formed. So now the equation is balanced. Like the carbonates, we have the sulfides. They also behave in a similar manner. Like carbonates always release carbon dioxide gas, sulfides, they always release sulfur dioxide gas. So in this case, we have CaSO3, it reacts with HCl, so it reacts in a similar manner to form CaCl2. Like carbonates release CO2, sulfides release SO2. So we get SO2 plus water. Whenever you see a carbonate, it releases carbon dioxide gas. Whenever you see a sulfide, it releases sulfur dioxide gas. In this case, again, now the equation is balanced. We have sodium bicarbonate. As I mentioned before, whenever we see a carbonate or a bicarbonate, it reacts with an acid, it always releases carbon dioxide gas. So in this case, sodium bicarbonate reacts with acetic acid to form the corresponding salt, which is CH3COONA. It releases carbon dioxide gas and water is formed. Based on this reaction, let's perform a small experiment. This experiment you can perform at home. Let's create our own erupting volcano. So you take a plastic bottle, you take some clay and mold it around the plastic bottle in the form of a volcano. Now in the plastic bottle, add some sodium bicarbonate and you can also add some soap solution to make it fizzy. Now get ready for surprise. Take some vinegar in a beaker and quickly add that bottle of vinegar or a beaker of vinegar to the bottle containing sodium bicarbonate. Observe what happens. As soon as you add vinegar, you have created your own erupting volcano. We have sodium bicarbonate. Sodium bicarbonate is the baking soda which you might have at home. So when you take this baking soda and you make it react with acetic acid. Acetic acid we know is vinegar, which is also available at home. So whenever these two react, it is a very vigorous reaction. As soon as this reaction takes place, it releases carbon dioxide gas. And it is released in such a large amount that it appears like an ejecting volcano. So you can perform this experiment at home. If we have one salt, it reacts with an acid to form another salt and another acid. So in this case, we have zinc sulfide and HCl. So we get the displacement reaction. We form ZnCl2 and H. H reacts with S to form the acid H2S. So now, this is the balanced equation. Similarly, if you have another salt, FeS, it reacts with an acid. Whenever one salt reacts with an acid, it forms another salt. So in this case, it forms FeSO4 and another acid. So in this case, again, it forms H2S. So the reaction of a salt with an acid gives another salt and another acid. So in this case, we get FeSO4 and H2S. Similarly, we have a salt containing nitrate and an acid. It reacts in a similar manner. We have one salt and one acid. So it forms PbCl2 and H reacts with NO3 to form HNO3. Now in this case, this is the balanced equation. One salt and an acid gives another salt and another acid. This reacts in the same manner. In this case, we have changed the acid, so it will form the corresponding salt. We have PbSO4. As now, in this case, lead reacts with sulfate and hydrogen reacts with nitrate. So it forms HNO3. So if we look at the reaction, this is the balanced equation. So whenever we have one salt, it reacts with an acid to form another salt and other acid. Like we have the case for acids, similar is the case for bases. When a base reacts with a salt, it forms another base and another salt. Let's take an example. We have a salt and a base. So one salt reacts with a base to form another salt and another base. In this case, how the reaction takes place? So it forms CuOH whole twice, and ammonium reacts with sulfate. So this is the balanced equation. Similarly, we have another salt, another base, so it will form FeOH whole twice, and sodium reacts with sulfate to form Na2SO4. So this is the balanced equation. Whenever one base reacts with a salt, it forms another base and another salt. Let's look at this reaction. We have a powder of ammonium chloride as we add sodium hydroxide, a reaction takes place. And now we use litmus paper. We'll see why we use litmus paper. You see that the color of litmus paper changes when you bring it on the top. This means that some gas is released. Which gas is released in this case? Ammonia is released. So when ammonium chloride, that is NH4Cl, reacts with sodium hydroxide, it forms NaCl, H2O, and ammonia gas is released. In this case, we know that when a salt reacts with a base, it forms another base and another salt. So the product should have been NaCl plus NH4OH. Now NH4OH is not a gas, but in the experiment we saw that some gas was released which changed the color of the litmus paper. So in this case, NH4OH is very unstable. Since it is unstable, it quickly decomposes to form H2O and NH3. So the reaction of NH4OH quickly gives us H2O plus NH3. As this NH4OH, ammonium hydroxide, is highly unstable. So whenever we get ammonium hydroxide as a product, since it is highly unstable, it gives H2O and NH3. So in the reaction we saw that the gas released was ammonia. If you get a wasp sting and you do not have any medicine with you, you cannot even rush to the doctor immediately. So what do? Let me give you a tip. Wasp sting is alkaline in nature. We know in order to neutralize an alkaline or a basic substance, we use an acid. And an acid readily available at home is vinegar. So you can use vinegar and apply it on the wasp sting. It will neutralize to form salt and water. So some knowledge of chemistry can help you in adverse situations like this.